Hey guys, Drifter here. Today I've got a fun little video for you about what if flat Earth were real? Or more specifically, what if several of the theories necessary for flat Earth to be a real thing were actually real? And I picked this topic today because it's something that I can make examples out of quite easily. It's kind of memey and clickbaity right now, but it serves the main point of this video of understanding the implications of scientific theories and how to use critical thinking to evaluate them, because it's not a skill that I believe is often taught in schools. When one scientific theory is wrong, especially a very big one like gravity, then loads of other systems and theories and fundamental knowledges that we have also have to be wrong. For example, if gravity is wrong, then most of our civil engineering, weapon systems, and travel methods like airplanes are also wrong, or they have some fundamental design flaw that means that we've just been getting lucky that they work right for all this time. And it would also mean that several of our other fundamental forces need to be reworked. So when you hear and see on the news, on the internet, wherever, this discovery changes everything, this redoes all of physics, blah blah blah, that usually means it's something very important because the applications of said experiment or theory cause other scientists to have to update and reevaluate their theories. But it's something that you need to keep in mind when you see pop science on TV and on the internet. It's just a great tool for evaluation, and it's one that I learned from Skeptic magazine many years ago. I don't even think they sell magazines anymore, but the guy in charge of their mail department said that one of the most common pieces of communication that they received was a theory of everything letter, most likely a theory of everything tome, a gigantic document. And there were some people, some of them crazy with schizophrenia, and other ones actually quite bright, engineers, doctors, lawyers, and otherwise genuinely well-meaning, intelligent people would send them a huge document with some kind of new physics theory. And it was most often a theory of everything, like a fundamental unifying theory that ties together gravity and general relativity and all the stuff that other physicists can't do. And the guy was talking about it, and one thing he said that struck me was that usually these theories explain one thing very well, even from people that may or may not have mental disorders. They've studied really hard and they understand one thing really well, and the theory that they send in almost perfectly describes that one thing. However, Skeptic magazine, being the trolls that they are, would often follow up by asking how it would apply to other fields and other studies and other sciences. And then those theories just start to crumble miserably. A scientific theory of everything, or a new fundamental force, is a theory that applies basically to every field of science that we know and requires them all to be rewritten, which isn't always useful or accurate. And we're going to start off today by just assuming that the Earth is flat. It's literally flat, just like the people on the internet tell you. It's a flat plane, you know, mountains and hills, but generally flat. Wall of ice around it that you can't escape or go over easily. Underneath us, it's just rock all the way down to an unknown end, if there is one. Maybe it goes on infinitely, we don't know. Above us, the air goes on for a really long time, and then we don't know exactly what stars and, you know, the sun is exactly. They're fixed up there. But there's no space. That's another very common one as well. Also, don't forget the sky rotates around us instead of us around the sky. And a very important belief to this group of people, and the one that we're going to focus on the most today, a fundamental belief, is that gravity isn't real. And I know that a lot of you will be like, well, dude, gravity is real. I pick something up and I drop it. And the same people that do flat Earth will tell you, like, yeah, same thing. Well, duh, that's because it's dense, and a denser object falls. Air is really light. Air has almost no weight. And they like to use density and buoyancy theory. If I remember correctly, buoyancy and aether theory were things that were used in like the 16 and 1700s as alternatives to gravity, but they didn't really hold out for a variety of reasons that we're going to get into later. But yeah, gravity isn't real, it's just density and buoyancy. All the governments have lied, and they've lied very well, encouraging complex alternative sciences. But something crazy happened. Somebody took a picture of the edge. They got on Periscope and live streamed the giant ice wall, and the government agents show up. So now we know everything. The whole world does, and we have to start reevaluating our scientific theories. And let's start with the big one. We now know that gravity isn't real, or at least it isn't accurate. That means that almost every single engineering equation from the last 300 years has to be reworked. We've got to redo everything from our equations for flight, to how cars balance their weight, to how spring works, to civil engineering with buildings, how the desk that you're probably sitting at watching this video is designed to support weight, the biomechanics of your body and implants, bullet physics, trajectory, Coriolis effect, missile launch patterns, what does the effect of density have on missile launches, submarine buoyancy equations for our nuclear submarines are almost certainly wrong, impact and terminal velocity equations, equations for things that bounce, wiggle, or deform like slinkies. You've got LCD screens and radio waves, and the things that make our phone work also may be inaccurate because the fundamental forces are no longer balanced as we understand them. And of course, Newton's original work. Yes, the fundamental set of rules that allow us to form modern physics as we know it are wrong, and we got to chunk them aside and rework them. On top of physics, we'll also need to revisit chemistry and particle physics in quite a few places as well, and one of them is on the topic of fundamental forces. That one of them, gravity, apparently doesn't exist, so the balance of our system with electromagnetism and strong and weak force and all the other forces are somehow wrong. We've got a wrong force. That means the other ones are at best incorrectly measured, and at worst, forces like electromagnetism are also incorrect, or there's additional forces or less forces or totally new forces. And the things that we use to understand how electricity flows, how to make magnets, how to design electronics, all of that stuff is also wrong. Maybe there's an entirely new force that we don't know anything about. It could also be that the Cavendish experiment, which is the one with the heavy lead balls that would hang and attract toward each other, because mass attracts mass in gravity, is some totally new force that we didn't know about. Or the Foucault pendulum is also describing a completely unknown force. We've got to revisit all this stuff from like the 1700s. Gravitational lensing on stars, assuming that we believe stars are real, is something totally different. The red and blue shift has nothing to do with gravity or lensing or speed of light. All those are wrong. Einstein's theory of relativity is wrong. We got to readjust what we know about gravity and what we know about time and what we know about time travel and particle physics. The equations that we use to build nuclear bombs, also wrong. And finally, we're going to need a new theory for why water increases in density as you go down. So the people who love density theory will talk about, you'll just sink until you're equally dense, right? Well, water at the bottom of the ocean has an insane density and an insane pressure. And if that were true, if we would just sink until we were equally dense, basically nothing would sink to the bottom of the ocean. You just could not make a thing that dense almost. We would have to rework literally all of science to accommodate all this new stuff that we've learned. And to be fair to the people that have alternative beliefs and the people that are following along with me, we have had to do this on occasion. In our scientific fields, after learning new things, we have had to radically adjust our understanding of physics. Typically, this is true these days of very high-level physics experiments on gravity, particles, etc., like the Higgs boson, relativity, Hawking radiation. All of these were super controversial and generally not well believed at their time until they were observed and then later they were accepted. In some ways, these are still controversial because they're very hard to work with, but they are observable and they're generally consistent with other observations, so we accept them. We then, after we've decided what it is that we need to replace, must evaluate the replacement theory as well. So it's two evaluations. What we're getting rid of, what we're replacing it with. Very simple thing. It's just like buying a car, pair of shoes, or whatever. And the replacement theory is that denser things fall toward the center of other denser things. Or at least density attracts density, kind of oddly similar to how mass attracts mass in gravity. But hey, that's a totally different thing. If this were true, there are numerous problems that arise that we don't understand, such as the fact that in a dome or a flat disk of some kind that just had stuff on it, and if density attracted density, then our atmosphere would probably have an irregular distribution of light and dense gas clustering, with the denser gases being toward the center of the flat Earth and the lighter gases being on the edges. And I don't mean up, I mean just like you could walk left or right and the gas would get denser. That would be the air that you breathe. Objects would sink until they reach the density equilibrium. So like if I dropped a brick in water, it would fall to like 10,000 feet and then it would just float right there. It would never go to the bottom of the ocean because with no accelerative force of gravity, it would just stop when it hits an equal density of the high pressure water, and we know that doesn't happen. At the edges of the Earth, goofy things would happen, like objects would probably fall sideways. They would try to fall toward the higher density areas in the middle. And if you made a big enough container and put, say, a very slow, barely viscous liquid in it, like tar of some kind, and then water on one side. So like your left side is like a super dense liquid that just about doesn't move, but is still technically liquid. And the right side is just water, and you drop an object in it. That object should fall toward the super dense liquid, like sideways, but that doesn't happen, right? And we know that these things don't happen, so the theory of buoyancy or density replacing gravity does not match with current observations. It doesn't fit our current science. And I'll add a caveat, that is of course unless there are numerous other forces and other theories and other phenomena that we know nothing about and have never measured, have never had a theory on, or can understand. And that's possible, but let's just say it's not very likely. And it's also not very logical to bet on. We've got, let's say, 50 knowns over here, things that are predictable, workable, reproducible. And then we've got some things that kind of work, and then like 50 ones that are just like, I don't know, maybe something new, I don't know, maybe. It's smarter to go with the knowns. And the reason that I say all of this is not necessarily to poke fun at flat earthers. It kind of is. I have people that follow me that are into that. But rather to explain a critical thinking skill, which is, when is it necessary to update my worldview? Our current scientific understanding was of course wrong about some things in the past, and I'm sure it will be wrong about some things in the future as well. That's just how this sort of messy process works. And in my brief time on this planet, I will almost certainly have to update my understanding about the world a couple more times as we advance in science. However, I want to do so carefully and trying to apply the new understanding that I've learned to old things and things that work. A new theory that doesn't match with observations and experiments, or is incompatible with other fields, is incomplete at best and usually a good sign of quackery. So if you want to replace what you currently believe and know, it would be best to replace it with something that is equally good and equally widespread and equally applicable, instead of something that's a little bit harder to kind of pin down. And guys, that is all for this video. I hope that you've enjoyed it, and I hope that you learned this little logical thinking tool of evaluating your beliefs and evaluating what you can and can't replace, and I hope that it helps you at some point in your future. Guys, if you did enjoy this video, don't forget to like, favorite, and subscribe. Drifter out.